Hello everyone. Welcome to the EasyPower Refresher webinar series. My name is Jim Chastain. I'm an applications engineer with Bentley for the EasyPower products. I'd like to welcome you all to this different take on arc flash compliance. This is not a magic bullet or a shorter way to do the study. This is actually, if you will, a different way of looking at the holistic problem. So hopefully it'll be something that's informative and will meet your needs. With that said, as we are in the habit of doing, we like to run a couple poll questions to get some feedback from the audience. And so the first question is, how would you describe your current status of compliance to NFPA 70E? No obligation or liability, just collecting some data at this point in the discussion to give me a little bit of an understanding of where people are coming at the topic from. Everyone attending today will receive a certificate of certificate of attendance. It will come via email, and there's nothing else you need to do. And we do appreciate you participating in the poll questions. So it looks like we have a quorum here. Here's how people have weighed in on the topic. So it looks like my target market is well suited, I think, for the presentation we're going to begin. And so the next question is, what seems to be your biggest stumbling block to achieving compliance? Again, this one's a little bit difficult to predict, so I'm really curious what the feedback is here. I'd like to call your attention to the handout section of the control frame in the GoToWebinar controls. There are 3 handouts there you're welcome to download, and we'll touch on what each of them are here shortly. So we're close to a quorum. Let's give this another 10 seconds. All right. Here's how folks have weighed in on this one. Excellent. Well, I appreciate your participation, and hopefully, as I say, we will give you some food for thought. Well, developing and implementing an arc flash risk assessment program that meets the requirements of IEEE 1584, NFPA 70E, and the OSHA standards is challenging, especially when you're trying to meet these requirements on a constrained budget with limited manpower assets. And it obviously requires proper planning and execution. And in my opinion, it's a good opportunity for some common sense approach. And so what follows are the 10 recommended steps that EasyPower recommends or presents. The first step is to acknowledge the hazard. A common misconception, and I've run into this several times talking to folks in my time with EasyPower, and that's the attitude especially from seasoned electrical workers. I've worked with 480 volts for 30 years, and I don't think I need to worry about arc flash. It's never been a problem for me. Well, the fact is, arcing faults can release dangerous levels of radiant heat, plasma, molten metal, and arc blast pressure capable of causing severe burns, injuries, and fatalities. Industry pundits estimate less than 35% of the U.S. companies are compliant to the current NFPA 70E standards. We do a monthly workshop on arc flash, and we average about 45% of the attendees to that monthly event reporting that they're just starting on the journey. And so this is information I think that's hopefully aimed at their requirements or their needs. The OSHA 1910 Subpart S mandates that any employee who might come in contact with an electrical hazard must receive electrical safety training. Now, OSHA does not specifically call for NFPA 70E training, but it is considered the industry standard for worker safety and compliance with electrical equipment. Now, just as a side note, I posit the question, did Ben Franklin discover arc flash protection? Well, it is true that he did discover lightning as a form of electricity. And he understood when air is the conductor, electricity can be dangerous. So his development of the lightning rod redirects the electricity to ground. Interestingly enough, that's exactly what the current technology advancements are doing in electrical systems. And as we get into the details of that, especially in the workshop, you'll find that the quenching systems that are now available from different manufacturers do exactly this. They redirect the arc energy to ground and thereby protecting the rest of the system. So applause for Ben Franklin. After doing dozens of these presentations over the years, I realized I really didn't include a definition of arc flash. And so I've cobbled together somewhat of an explanation. Since the days of Edison and Tesla, high-energy explosive accidents occurred in electrical systems, damaging equipment and injuring workers. And the exact cause was not known. Some labeled them the acts of God. It was in the mid-1950s that the U.S. Navy observed that most of these events seemed to be happening when workers were in or moving something about the equipment around while it was energized. And it was in the late 1980s that an engineer by the name of Ralph Lee presented papers at an IEEE conference that defined the arc flash event. It's a self-sustaining high current event through plasma arc. The energy has ionized air creating a plasma, and it radiates large amounts of energy, both in physical energy, kinetic energy, and heat energy. The significance is this path is not confined to system hardware. And so Lee's model estimates the amount of energy released over time and correlates that heat damage to unprotected skin. Now, just as an example, this is what the bolted fault test setup looks like when you're testing breakers to verify that they can withstand a maximum amount of current. And so this is a substantial fault between all three phases. We call it a bolted fault, and it's a piece of copper. It looks like it's about 1/4 inch thick and 3 inches wide, covering all three phases. Well, as a comparison, when they do an arc fault test setup, they initiate the arc with this little wire between the phases that melts instantly and has enough energy behind the pulse that it creates the plasma. And as long as that plasma can touch the electrified buses, it will propagate this high energy event. So the question is, do you feel lucky? Talking to these people that don't believe it's a problem. Thinking the problem does not exist because you've not personally seen it could mean you've been lucky. Well, being unlucky one time could be a very bad day. So the step one is to acknowledge the hazard. Step two is to understand your risks and responsibilities. An effective electrical safety program that includes not only arc flash hazard assessment is not only the right thing to do, it also can mitigate the risk of millions of dollars in losses that can arise from a single incident. These would include costs due to medical treatment for victims, legal defense fees, OSHA fines, lost worker productivity, and potentially increase in insurance premiums. It is true that electrical hazards are low frequency events. Industry studies have shown that less than 0.2% of lost time injuries are due to electrical hazards, and at the same time, they represent 3.6% of occupational fatalities. On the other hand, electrical hazard events or accidents are the 7th leading cause of occupational fatality. And that this last line is the one to pay attention to. It's the 2nd most costly workers' comp claim, according to these studies. So even though it may not be a frequent event, it's costly when it does happen. Recently, I was talking to, I believe, a purchasing manager at a facility locally, and I asked, is your facility compliant with NFPA 70E? In other words, do you have arc flash labels, for instance, on the equipment? And her response surprised me. She said, that's the reason we have an electrical contractor do all that. Well, the reason that I bring this up, and very often it's a common path to try to divert some of the risk involved, I think there's a misunderstanding of where the standards place responsibility. For instance, in NFPA 70E, in Article 130.5, stipulates the owner of the electrical equipment shall be responsible for the documentation, installation, and maintenance of the marked label. Now, often equipment installation contracts, so there's kind of a second order effect to this. I've seen equipment installation contracts require that equipment be labeled per NFPA 70E, not just the generic label that the National Electric Code requires, before the owner of the equipment, the new owner of the equipment, takes title and accepting responsibility. The point is, it's very difficult to transfer liability, employee safety, to a third party without some careful consideration. Step 3 is define the path forward, and this can be different based upon your situation. So you want to define your specific measurable goals, and then determine the gap between your current electrical safety program and those goals. And based upon this, you want to develop an action plan and a timeline. Timeline should include generating up-to-date electrical drawings. I've visited subcontractors, suppliers for the Boeing aerospace company that had the most advanced metal working technology available. And yet, as I was talking to the facility manager, he said they did not have a one-line drawing of their electrical system, let alone something that was up to date. And I couldn't understand how that could be possible. And he said, well, during the last downturn in the industry, they laid off all the maintenance people. And as they started to pick back up and had a growth spurt, they weren't keeping up with the changes in the facility. And so there's no way you can even claim to have a modicum of safety, electrical safety status, if you're not even sure you're turning off a certain piece of equipment with any individual breaker. So having up-to-date electrical drawing is paramount and a good starting place for any discussion about electrical safety. In addition, you should have a short circuit study that includes equipment duty verification. Equipment duty is a test that verifies based upon the worst case event at that bus in your system, that the equipment will operate properly. And in addition, you should have, or especially if the equipment has been installed for some period of time, you should have a protective device coordination study. Usually these are done when you have a first design and commission the equipment, but over time things can be adjusted or replaced or tweaked, and they could interfere with the protective device coordination of the plant. And then finally, an arc flash risk assessment would be the ultimate goal as far as the technical requirements. Now, to generate an accurate one-line diagram is relatively simple on a new design where you have all the details of the equipment, the protective devices, the cable links, and the nameplate data. On the other hand, if you're at a plant or a facility that's been in operation for a number of years or decades, it could be very difficult to collect the data. And consequently, there are many cases where over 50% of the man hours or total hours to do a study are required just for collecting data and building the model. Now, the point I'd like to make is this can be outsourced, but at the same time, it presents a significant training opportunity for maintenance personnel and employees that need to learn or should learn both about the equipment and about arc flash. So being involved or having your team involved in data collection and then building the CAD model to create the database could be not only a significant cost reduction as far as the cost to outsource the function, but it also could be involved in training personnel to understand the hazard. And so one of the things I would suggest is to utilize available resources. For instance, one of the things on the handout download from this webinar is what's called the Practical Solution Guide to Arc Flash Calculations. It's free if you download it from the website, although you could purchase it off of Amazon for a hard copy for $70. But again, it's a free resource. It's available now. And you can download it from the control box. In addition, as I mentioned earlier, we, EasyPower, broadcasts a no-cost arc flash workshop monthly. It's a 4.5-hour event, and we limit the registration so that people can ask questions and get feedback for both detailed questions and general technical questions. So again, that's free and it's available on the workshop on the EasyPower website. Collecting utility data, or requesting utility data is relatively easy. Sometimes it's difficult to receive based upon how large the utility company is, how remote it is. And so one of the things in this handbook that is discussed is what to do if you can't get information from the utility company. But assuming that you're working with a company that understands the need for doing arc flash, they will provide the voltage supplied and the available short circuit current for both maximum three-phase events and single-phase to ground events. And in addition to the current level, it's also the impedance at which it's delivered. And this is required for generating the CAD drawing, the data file. Likewise, the information on transformer substations. For EasyPower requirements, all the information is on the nameplate of the transformer itself. And this includes the kVA rating, the impedance ratio, the configuration, and the temp range. And by the way, The demo copy of the software is free, and you're welcome to download it from the website and build your own one-line diagram as a trial. So this is an example of a two-winding transformer data entry dialog box. And all the required data is indicated by the red quotation mark or red dot on the form. And system elements that are important, there's cable data. Again, it presents an impedance to any short circuit current. And so this is information that will be recorded from the markings on the cable itself. Again, if you have an older facility, the cable marking can be obscured or dirty. And so it presents a problem, especially if you're trying to collect the data while the equipment's hot. And the recommendation is, rather than trying to move cable around to see what the markings are, wait till it's shut down and safe before you collect data on the cables themselves. Likewise, motors, heaters, and lighting panels, all the loads need to be documented. And in the NFPA 70E and IEEE 1584, the recommendation is any load or any motor greater than 50 horsepower should be included, because it during a fault, it acts as a generator for some period of time. And then one of the things you'll learn if you attend the workshop is that time is everything in Arc Flash. And so the timing elements are particularly important, and collecting data on breakers, fuses, and relays involve manufacturers' part numbers, types, styles, and then the dial settings for the trip units. Likewise, on fuses, the size, manufacturer, and the model are generally, I don't say relatively easy to get, but they usually are marked on the fuse holder. Interesting side note, during data collection, you want to make sure that if you're inspecting a three-phase system, that you look at all three phases for fuse information, make sure that the fuses are identical and you haven't had someone replace a fuse with something that was close just because they were trying to keep the plant up and running. And likewise for relays, the details on the set points, the dial settings, the timeline, all this is used in protective device coordination. So doing the short circuit study, again, the software does most of the hard work as far as the calculations. And what you will be able to determine is the worst case fault current at every bus, and be able to examine the results, simulating a three-phase voltage fault, a line to ground fault, line to line faults, and all current sources during the fault, including motors, generators, and the utility, all of which can change over time. And then, as I mentioned, part of the short circuit study you want to make sure is generating an equipment duty study to make sure the equipment that you're depending on for operating during a fault will be able to withstand the worst case fault itself. Protective device coordination is referred to as selective coordination to improve system reliability. So minimizing unnecessary shutdowns is a real goal, and a good time to do this study is during a short circuit or during an arc flash assessment. Protective device coordination is not required by the National Electrical Code except for emergency and critical loads, but it's a good check. It's good to check the impact on arc flash hazards. Frequently, you will find that coordination actually countermands mitigation. And so a system that has protective device coordination could actually end up having higher incident energy as a result. Then the arc flash risk assessment takes the results of all these foregone studies, and at least in EasyPower allows you to follow the IEEE 1584 guidance. Part of that assessment is to determine the system modes of operation, determine equipment requiring hot work access, consider the working distance for removing the cover. The reason I emphasize this is that if equipment is needed to be worked on while it's hot, which usually is the goal of understanding the arc flash hazard, that may be different. The working distance for doing the hot work may be different from the label working distance that's used for general information. And so understanding that is an important part of determining where and why you do the arc flash risk assessment. If you're not going to have equipment that's worked on while it's hot, then it's the hot working distance isn't necessarily applicable. So again, this all goes into a discussion of what to do with the arc flash risk assessment results. You want to consider mitigation options for anything that's going to be exposing workers to the hazard. Need to understand which equipment needs to be labeled and what your policy is for propagating that information or training people to use that information for their protection and the safety of others. And then as the last line of defense, determine the protective measures and PPE requirements for anything that's going to be exposed to personnel while it's energized. So then after that, you want to take stock of your situation. So step 4 is to analyze where you need to do hot work, where you need to do mitigation of elevated energies, what arc flash boundaries I can change or deal with, and then determine, especially for electroshock safety, limited and restrictive shock boundaries. Now again, this is relatively easy to produce with software, and what you're looking at here is an indication of the one-line diagram and the hazards involved during a worst-case fault at each bus, and at the bottom the arc flash hazard report, which is literally required as part of an arc flash study. So that brings us to step 5, and that is prioritize hazard elimination. In the early days of 1584, the focus was, the early days of arc flash recognition, was putting on more PPE so personnel could work on equipment while it's hot. And that was the industry's direction in the early days. And it wasn't until 2018 or so that the focus started to become more on eliminating the risk rather than just trying to isolate personnel that had to be in the area. And so what was promoted was referred to as a hierarchy of risk control methods to minimize influence of human error. First of all, eliminate the hazard. In NFPA 70E, that's referred to as electrically safe work condition, where the equipment's been de-energized altogether. And again, as I mentioned, without having a one-line diagram that's accurate and up to date, you can't be sure that that's the case. So only working on de-energized equipment is the first approach. The second is potentially substitute or replace with safer equipment. In today's market, there are trip devices for relays, fuses, and breakers that are microprocessor based and can be set up to reduce, on a temporary basis, reduce the exposure of personnel working on the equipment while it's hot. And so considering that type of a substitute or an application where you know you have to have personnel working on hot equipment could be a good substitute or a good choice. Engineering controls for remote operation. And this is another popular approach. You'll find by attending the arc flash workshop, the most dangerous time for arc generation is when you're opening the breaker in the piece of equipment. And so being able to do this by remote control places the worker beyond the hazard zone and can mitigate the problem considerably in a worst case event. Likewise, improved training and improved documentation and focus on safety has seen positive results. And then as a last line of defense, PPE and training personnel for the proper use is an absolute must if once you get to this point. Now, I mentioned de-energization in NFPA 70E. The procedure that guarantees that is called lockout tagout, and it's detailed, and it can be different based upon how extensive your facility is or how complex your workforce. But the point is to be able to develop and train workers, and retrain workers updated on the equipment to be able to lock out and tag out and understand they need to use the proper PPE to test the equipment for lack of power after it's been de-energized. So that's a critical point, and it belies the fact that if you're trying to avoid an arc flash study, you're missing the point. And then finally, having some physical guard against accidental power turn on while someone is in the area is the goal of the tag out, where locks will be controlled or keys to locks will be controlled by the personnel doing the work. So again, the more complex the system or the larger the organization, lockout tagout is a significant step in a safety plan. And as I mentioned, PPE is a last line of defense. So step 6 is to ensure the proper selection for the assigned task, train qualified workers in fit and body coverage, and make sure you review care and cleaning, which is appropriate per manufacturer's instructions. Now, I don't want to get too morose about this, but I emphasize that if you look at the data sheets for PPE, they are not guaranteeing that they're going to protect personnel in every case. And in most cases, they give us a rating, say 12 calories down to 1.2 calories per square centimeter. 1.2 calories per square centimeter is the line of demarcation that if a human is exposed to 1.2 calories per square centimeter for 1 second, there's a 50% chance of developing second-degree burns on unprotected skin. So the point for bringing this all up is even if I follow all the rules for PPE selection and use, I still have a 50% chance of being harmed. But the good news is I should be able to recover without too much scarring. I'm not trying to be facetious. Step 7 would be energized work permits. Again, this is required by NFPA 70E for work over 50 volts. And the energized work permit should list the work to be done, the safety measures, the hazards involved, the procedures to be followed, And then I believe an important element that shouldn't be overlooked is the signature requirements for management and technicians both. Management, this is company management, I believe has to recognize that they are authorizing personnel to work in an elevated hazardous situation, and all steps have been taken to protect the worker, not just putting on more PPE. So this is an excerpt from NFPA 70E, and it's also a printout from EasyPower for a hot work permit, and it includes all those checklists and the results from an arc flash study and the electroshock shock study. So again, making sure that this is required for any hot work, I think it's an important part of an overall plan. It's important to understand that an arc flash risk assessment is not a one-shot and done situation. The safety program that includes an arc flash study is more than just the study itself. It's important to document the complete electrical safety reference for the organization, and the arc flash safety program be part of it. And that's the purpose for NFPA 70E to be as a guideline in trying to follow NFPA 70E. You're satisfying the OSHA requirements, or you're illustrating the intent to satisfy the OSHA requirements. The reason that that's emphasized, if you choose not to follow NFPA 70E, you best have documentation that describes what your safety program is, and make sure you're training your people to do so, to follow it. And there's some reason that you believe your system is more appropriate for your organization than NFPA 70E. Now, in any case, you should have a safety program that's reviewed periodically and includes the ability to audit and accommodate changes both in standards, the personnel training, and the facility equipment itself. Training is an important part of this whole discussion. It's required for all qualified workers and operators. It should include the company work procedures and policies and evaluation of system conditions. I didn't focus on it, but during data collection, actually, I'm 2 slides ahead of myself. During data collection, it's important for the data collection team to ascertain the effective status of equipment such as breakers, protective devices, and even panels or wire structures, to evaluate their condition in terms of maintenance and history of viability. If it's understood that the equipment may not work as required during a fault, there should be the ability to kind of include that observation in the data collection system. So training should allow for auditing and changes in the system, both equipment, procedures, and personnel. Data has shown studies, mitigation, and PPE and labels aim to reduce the effects of an accidental event. And frankly, it's based on the worst case at each bus. While as training, refining procedures, and a focus on safety have a better chance of reducing the frequency of events and potentially have a proper response to single-phase ground. The point for this is the most common fault in the system, in the industry, is a single-phase to ground. All the calculations for arc flash are done in a 3-phase. Its model only includes 3-phase worst-case events. So the point to be made is when a single-phase fault that doesn't elevate to a three-phase fault is generally a near miss, and it may not cause as much damage, but it should be an eye-opener and a wake-up to make sure that you understand what caused that event and how best to prevent it, which primarily is going to be training and improvement in procedures. In my opinion, the evidence of a mature safety program is when you have qualified worker buy-in. And what I mean by that is suggestions for improvements come from the workers themselves and are available in discussions of regular safety reviews or safety meetings. And again, the system is available for audit and built-in positive feedback for people willing to or trying to improve the safety status, especially for the day-to-day workers. So then step 10 is the equipment maintenance, and this I referred to a little bit earlier. NFPA 70B is now released as a standard, and in the past it's been issued as a recommended practice. Now it's mandatory with a quotation mark. But the purpose is to provide for the practical safeguarding of persons, property, and process from the risks associated with equipment failure or malfunction. And so the benefit is they've given us some ability to categorize equipment as we're doing the data collection assessment. So condition 1 would be something that's obviously in good condition and has been properly maintained. Condition 2, where maintenance shows changes or potential need for improvement, and it has some flags for predictive techniques or from continuous monitoring since prior assessments are addressed. Condition 3, changes in operation are noted, and unaddressed flags for the continuous monitoring system where there are important actions identified from predict. So this is equipment that's still operable, but it's not receiving the attention that's been noted or flagged before. But then there's, if you will, the bad stuff, the non-serviceable equipment that's creating an imminent risk of injury or negative health. So access by unqualified persons shall be restricted. Non-conforming equipment with characteristics not conforming to any of the above conditions shall receive correction before using it normally. And then similar to NFPA 70E, normal operating conditions. In other words, if it's not normal operating conditions, it's in bad shape and poses a risk, then you need to perform preventive maintenance immediately. Now, so that, in my opinion, constitutes the 10 steps for evaluating what your options are. The point to be made is that this isn't has to be done all at one time. Based upon your gap situation, you could find a reliable, trusted source with experience in arc flash assessments and mitigation, and balance your goals and resources against a commitment to a realistic plan, including training. So any place you can have your personnel involved in not only the data collection, but the assessment process, you will benefit or reap the rewards for their recognition of your focus on safety. Thank you for joining us today. Again, there are a lot of resources on the easypower.com website, and I appreciate your feedback. You're more than welcome to contact me, Jim Chastain at Bentley.com. Have a good day.